Hello everybody, this is Ramon Alcarria and welcome again to this course, Network Control Systems with Arduino, an Introduction to Technology, Programming and Robotics. This is Module 5, Location and Storage, and in this first lesson we will learn how to extract and correctly represent positioning information coming from a GPS device. First of all, we describe the global positioning system and how location data is delivered by common positioning devices by using the NMEA protocol. Then I will describe a well-used GPS module for Arduino, easy to incorporate to our projects. Finally, I will explain a practical approach to connect and configure the GPS module, processing location data through the Tiny GPS Plus library. GPS is a space-based global navigation satellite system that provides location and time information. The project was started in 1973 to overcome some limitations of previous navigation systems, such as speedometers or traditional maps. GPS was created by the US Department of Defense and was originally run with 24 satellites. It became fully operational in 1984 and freely accessible by anyone with a GPS receiver. All satellites transmit a navigation message with a length of 1.5 kilobits, using bitrate 50 bits per second. Hence, the complete transmission of one message consumes 30 seconds. One message is separated into 5 subframes with equal length of 300 bits. Each subframe is composed of 10 words. The NMEA 183 protocol is designed for communication between marine electronics equipment and other devices. The serial communication between devices is performed in the form of sentences in ASCII code. Transmission rate is 4.8 kilobaud. The latest version of general NMEA protocol, that is 4, contains 59 types of sentences. Several of them are used for GPS navigation only. All sentences used by GPS receivers start with prefix GP. Location information is contained in the GPRMC message. It is a comma-separated ASCII text containing, as you can see, the time of fix, receiver status, coordinates expressed in latitude and longitude, speed, and course, among others. A well-used GPS module for Arduino, easy to incorporate to our projects, is the GPS 6M-V2. This module incorporates a design that suppresses jamming sources and mitigates multipath effects, giving excellent navigation performance even in challenging environments. It integrates an antenna and room memory with a fully embedded calculation algorithm. For more information about this module, you can look to the module datasheet included in the documentation. Well, the first approach is to connect the module to our Arduino board in order to get the raw text. We have the power supply input, ground, and 2 transmission and reception pins. The ASCII text will appear in the serial monitor as shown. When you create a new serial connection, remember to specify the reception port as the first number, 10 in the example, and the transmission port at the second number, 11 in the example. As Arduino's transmission port must be connected to GPS reception, that means that transmission in GPS must be wired to pin 10. Finally, we extract information from NMEA messages. To do that, we use a parsing library that is called Tiny GPS Plus, which extracts position, date, time, altitude, speed, and course. Remember to include the library in our sketch. We can reuse our previous code or modify some other example. I recommend the Arduino GPS example from Lesson Studio. Solution is included in the module's documentation, although I strongly encourage you to firstly try to figure out the solution by yourselves. By using the GPS library, you will see in the serial monitor location information such as the registered number of satellites, coordinates, speed, and altitude. Thank you very much for your attention, and see you in the next lesson.